Welcome to part 2 of our pipe drafting series using manual AutoCAD and ProPipe applications. As you may recall, in part 1 we discussed pipe, and in part 2 we are going to be looking at pipe fittings. Those will include the butt weld applications, they will include socket weld and screwed applications, as well as flanged. We will also be discussing cast iron and plastic fittings. As you may recall, the pipe was used primarily to make straight runs throughout the piping facility. In many instances you're going to have to make turns, and pipe fittings are the items that are used to do that. Pipe fittings are used to change direction. They are also used to make branch connections, make reductions in line sizes, and so we're going to be looking at several different fittings that are going to allow us to do that. As we think back about pipe, recall that there were many different schedules or pipe weights that pipe was manufactured out of. The same way is true with pipe fittings. Pipe fittings are manufactured as standard weight, extra strong, schedule 160, and double extra strong. And also, like pipe, fittings are manufactured with either beveled ends, they can have threaded ends, plain ends for socket welding, or in this case, flanged ends. So let's look now at the most common fitting that we have, the 90-degree elbow. The 90-degree elbow is used to make changes in direction of a piping run. As we look at this, we can see that elbows can turn either up, they can turn down, any angle in that axis. So as we look at the 90-degree elbows, be aware that they are used to change the direction of the piping system. We have 4 elbows that we want to show you. The long radius elbow, then we have a short radius elbow, we also have a reducing elbow, and then we have the mitered elbow. The mitered elbow, as you can see, is actually not a fitting but a manufactured run of pipe, and we'll discuss that in greater detail in just a little bit. The 90-degree long radius elbow is again the most commonly used fitting in the piping industry. Any turn that has to be made, if it's not made from a pipe bend, has to be made with an elbow. The critical dimension of a piping elbow is its center to end dimension. That means from the center of the fitting to the end of the fitting. And what we're going to do now is going to show you how we can again determine this dimension using our fitting dimensioning charts. Before we look at the dimensioning charts, let's first talk about the symbols used to describe the elbow on the drawing. The elbow can have several different appearances depending upon the point of view of the viewer or the drafter. As you can see, the elbow can have an appearance of this from the front, or it can have an open end appearance, or it can also have a rear or a back appearance. What we're going to be looking at now is the drafting symbols used to define the 90-degree elbow. For a elbow that is 12 inches or smaller, notice that we are representing the symbol as a single line symbol. For pipe that is 14 inches and larger, we are representing the elbow as a double line symbol. So in each of these cases, we must identify to the reader of the drawing whether you're looking into the open end of the elbow or the back side of the elbow. Now, as far as our dimensioning chart is concerned, let's look at the dimensions required to draw our elbow. When we spoke about pipe, we had mentioned that piping drawings are drawn to 3/8 inch scale. Well, the same is obviously going to be true for your fittings. The required dimension for the 90-degree elbow is, again, its center to end dimension. Notice in this figure, the center to end dimension is also equal to the center line radius. It's this center line radius dimension that is critical when we construct the 90-degree elbow. You will happen to notice that the center to end dimension is equal to 1 1/2 times the nominal's pipe size. As an example, let's suppose that you have a 6-inch 90-degree elbow. 1 1/2 times 6 is 9 inches. So therefore, the center to end dimension of a 6-inch 90-degree long radius elbow is 9 inches. That information is found off of our fittings chart, and as you can see here, nominal pipe sizes 6 inches. Our A dimension, which is again the center to end dimension, is shown as being 9 inches. The procedure to draw the 90-degree elbow is shown in Chapter 2 of the textbook. In this instance, we are using a 14-inch elbow. 1 1/2 times the nominal size, or 1 1/2 times 14 is 21 inches. So therefore, from the intersection of the two center lines of our pipe, we will measure 21 inches both to the right and below the intersection in order to establish the ends of the elbow. In step 2, we have measured 7 inches above and 7 inches below those two endpoints. Again, 7 inches being half of our 14 on both the right and the bottom ends of the elbow. We have then simply used a circle template to construct the arcs connecting those two endpoints. Notice that we have a center line radius, we have an inside radius, and then an outside radius, which is establishing our elbow. We simply draw vertical lines to construct the ends of the fitting. Again, for 12-inch and below, we are only using a center line radius. We do not have an inside or an outside arc to represent the elbow. So therefore, only 1 1/2 times the nominal size. In this case, for a 12-inch elbow, it was 18 inches. We have an 18-inch diameter arc representing the elbow. So now let's look at how we would draw this elbow in AutoCAD. As we can see here, we already have the two center lines for an intersecting turn in the pipe. What we're going to now do is use the offset command to establish the ends of the elbow. Knowing that we have a 14-inch elbow, 1 1/2 times 14 will again give us a 21-inch center to end dimension. So I'm going to set my offset measurement to 21 inches. I will be offsetting both to the right and down below to establish an intersection. From this point, I'll be using the arc command. The center of our arc will be at the intersection. The start point of the arc will be at this intersection, and as you can see, we can construct our arc to represent the center line of the elbow. Once again, using the offset command set to a 7-inch measurement, we can offset the center line below and above to establish our 14-inch measurement. By extending the lines throughout the end of the elbow's large diameter, what we're then able to do is to trim and create our long radius elbow. We can continue on by erasing the center lines if necessary, and therefore we have our elbow created. Of course, in double line piping, this would be a center line representing the center line of the elbow, and of course our pipe would continue on from this location on out. Let's look at how we would now draw this elbow using the Pro Pipe Saw.